Okay, so we're going to take a second and talk about 2.7, which is curve fitting. Basically, you're trying to fit a line or match up a line to a data set that you have. So you have lots of information. Your job is to make a line fit up with that data. Okay? What we're looking at is how can we represent specific scatter plots and their information with linear models. Okay, and when we say linear models, we're just talking about lines. In order to be able to talk about this, there's a few things we need to talk about. Okay, the first is regression. Regression is something we're going to study a lot throughout the year. We're going to study linear regression, which is using linear models. We're going to study quadratic, exponential, cubic, all sorts of good things. Okay, regression is the statistical study. So we're doing a little statistics right now. The statistical study of the relationship between variables. Now when we talk about this regression, right now we're looking at linear regression. Because we're mapping our data to a line. Okay, so we're mapping our data to a line. Okay? But in general, regression is this whole study and mapping it to any sort of curve. That's why it's called curve fitting and not line fitting. It's a curve. We could look at a parabola. We could look at exponential growth, that kind of a function. Okay? When we talk about this relationship in terms of regression, we look specifically at correlation. Okay, what's the correlation between our two values? Correlation is the strength and the direction of this particular relationship. When we talk about the strength, we can say data is either strongly related or strongly correlated, or it's weak. Strong means that it's all gathered kind of around the same place. Weak means that it's not so much. Okay, so we're talking strong or weak. How well or how tightly does our data group around a particular line? How close is that relationship? That's the kind of things we're talking about when strong versus weak. Okay? And then the direction. Positive or negative. That's looking at the slope a little bit, the slope of a particular line. A positive correlation means as one data value rises, the other data value also rises. Negative means as one goes up, the other goes down. So positive or negative. When we talk about direction, we're kind of looking a little bit at slope. The slope of our line. So is it strong or is it weak? And then is it positive or negative? Strong positive would be a way to describe. Weak negative would be a way to describe. If there's no relationship, we say no correlation. There's no relationship between the two data points. There's no connection between them. Okay? When we have that strong correlation between two data points, we can write what's called a line of best fit. Okay? And a line of best fit is a line that most accurately represents the data. It may not be a perfect representation, and that's that idea of strong versus weak. The stronger the correlation, the better the line will represent your data. The weaker, then your line isn't going to be perfect. So we really use line of best fit when we have that strong correlation. We write this line of best fit the same way we've been writing equations of lines all along. We gotta know slope, we gotta know points, and then we can write the equation of a line. Okay? What this line does for us is it becomes very useful for making predictions. Prediction. Just one. No, it's useful for making predictions. So like you can look for patterns. You can use the line of best fit to look for a pattern in your data and go, okay, if this pattern holds, I think that, and then you can finish your prediction. Okay? So we'll do a lot with drawing lines of best fit. Now a lot of this we can do on our calculator, and so we'll work on graphing calculator stuff with this as well. Okay? Just a little bit of practice with correlation. Strong versus weak, positive versus negative. Let's look at a couple graphs. First one, hours of study versus test scores. Okay, the data, it's positive. As people study more, their test scores go up. So we definitely want to say this is positive. Now, is it strong or is it weak? Well, it's all pretty much gathered right around that line. So we could say this is a strong positive. There is strong positive correlation here. Okay. Next one, now let's look at this one, height and versus weight. There's definitely a positive correlation here. Definitely positive. As your height goes up, your weight goes up. As your weight goes up, chances are your height goes up. Okay? However, this one's a little bit weaker. And when we say it's weaker, look how far away some of these data points are located off the line. This one before was strong. It was all pretty much right on top of the line. The line kind of really represented those data points well. Now, when we look at this height versus weight one, we're slowly branching off the line. Everything's kind of gathered around it, but it's more of a weak positive. Okay? This one's definitely negative. Holy cow, look at it going down. Oh my gosh. And you know what? It's pretty much right around that line. There's not a lot of outlying points. So this is strong negative. Okay, talking about employment rate versus how much people invest. When the employment rate is low, people are more likely to invest. As one goes down, the other goes up. That's that idea of negative. As one goes up, the other goes down. Okay? When unemployment rate is high, people aren't working, they don't have extra income, so they don't invest as much. Okay? So this one's strong negative. Okay, see what you think. Take a guess. Okay? This actually has no correlation, like holy cow. It's just a cluster of math happening. Nothing good. And that makes sense because look at birth month. I was born in October. So if you were born in October, it doesn't determine our height. There's a lot of short October people. There's a lot of medium height October people. And I'm sure there's some very nice tall October people as well. Okay, there's no correlation here. No correlation. We can't find any relationship between these data points. Bummer, dude. Okay, try this one. Take a guess. Oh, no, just kidding. There we go, try this one, take a guess. Now the line's kind of drawn in for you. Okay, looking at the relationship between how long it takes for Old Faithful to erupt between the two times, and then how long it erupts for. Okay, it's definitely positive, that's for sure. Now are we a strong positive or weak positive? This one's a little bit tougher. Okay, we do have some good data grouped right around our line, and it all pretty much follows that line. So even though we have some points further out, we're going to say this is a strong positive. Look at this one. Pretty strong. Reaction time versus age. When your age goes up, your reaction time goes down. Okay, we're going to say this is strong negative. Young kids have a slow reaction time. Look at this. You got 6-year-olds. Reaction time of 0.8 seconds. 18-year-olds. 0.4 seconds. Half. Twice as fast. Okay? Now, when we talk about this, when we talk about correlation, we can talk about how well a data set really is. How strongly correlated is it? Okay? We use the variable R. Okay? R is the correlation coefficient. And what it tells us is how well a data set is fit to a particular model. Now here our models are lines, so how well it fits with this line. Okay. For R, we're looking at a number between -1 and +1. Okay. When R is -1, we are looking at a perfect line that has a negative slope. That does not mean the slope is -1. R is not the same as M. This correlation coefficient is not the slope value. Okay? The slope could be -10. It has to be negative and the line has to be perfect. Okay? Same thing over here. We could have a perfect line with positive slope. And that would mean we have an R value of 1. Okay? So that means our line is positive. When one data point goes up, the other rises also. It doesn't say the rate it goes up, that would be the slope, but it says it all goes up exactly the same. We can draw a perfect line. Okay? When we have R equal to 0, that means we have no correlation, no relationship between the data. That's kind of like that birth month versus height. No correlation. Okay? We're going to look a lot more at R as we get into plugging stuff into our calculator. Okay? That's definitely when we'll tackle that. Now, with all this fantastic stuff being said, we need to talk a little bit about correlation. Because there's a difference between two things being correlated and one causing the other. There is a phrase you may have heard. And that phrase says, correlation does not equal causation. Just because two variables are related does not mean that one causes the other to happen. Okay? Now, looking at this graph, you have two graphs here. You have this bluish looking one on top, which is the divorce rate in Maine, kind of follows this pattern. And then you have how much margarine people are eating in the United States. So this is margarine in the United States. Now, it looks like those two follow the same path. They are correlated. They pretty much match each other exactly. Okay? However, that does not mean that eating butter causes people to get divorced. Just because they're related does not mean one causes the other. Okay? Correlation does not equal causation. Let's look at another example. Age of Miss America versus murder by steam, hot vapor, and hot objects. Here's how old Miss America was. She's 24. Dipped down to a solid 20.25, which would be 20 in 3 months. Climbs back up to about 24 again. And then in 2008, when I was Miss America, I was 19. Okay, I'm lying. I've never been Miss America. Sorry. Okay. And then, murders by steam. We got lots of people dying due to death by steam or other hot objects. These follow similar patterns. That doesn't mean that in 2008 when I was Miss America that I caused people to die by steam. No. Okay? What that means is that these two data points just happen to be related. Just because they're related does not mean that one causes another. Okay? It doesn't mean that if Miss America is 24 again, all of a sudden we're going to have a high rise in steam death. That is not what that means. Correlation does not equal causation. That's something I want you to get through your brain. Just because two things are related doesn't mean that they impact one another. People who died by becoming tangled in their bed sheets. Graph for that looks something like this. Okay? These people had some trouble.